Okay, so what do I want to talk about next? I want to talk about the idea of scattering, in particular, light scattering around in our volumes here. So to that effect, let's make a new kind of light. It's called a point light. Point light is basically just any old light that it has a center and it shoots rays off in all directions. Um, in particular, though, because I wanted to illuminate our volume from inside with this. So I'm gonna move this guy down kind of into the source of it here. This is it kind of on the first frame. I figure that's a good spot for it. And let's get rid of this thing too while we're at it. And I'm gonna come back over the 96 frame. Great. So the point light, much like the spotlight, in fact, the only thing difference between a point light and a spotlight is this enable spotlight option. And so the similar thing in particular is the idea that these things attenuate. They fall off quadratically by default because physically correct is on. So I already know I'm gonna need to make this probably pretty bright in order to really see this in my render. Um, let's see what we get out of that. So I expect to see some sort of kind of supernova-ish looking thing here in the middle. Okay, that's more or less right. I wonder if we can make it we can make it spread. We can make it actually reach further into our thing here by bringing the amount of shadow down. So the shadow intensity is 1. 1 basically means like when these send out shadow rays and it hits an object, well then the light is completely occluded because it's blocked. And that's because this is 1. But if you set this down to like something like 0.5, well, now what would normally completely block it is actually only going to slow it down by half, maybe. So in this case, I would expect to see the light travel further out into it, and of course, there it goes. So now it's still getting slowed down, and will be stopped eventually. So somewhere out here, we see that the color actually kind of does reach the color that it was before, the intensity that it was before. But it took longer for it to do that. Now, this isn't actually scattering. This is a very cheap way to make things look like they have scattering. So if you're really starved for resources, because actual scattering is going to be very computationally expensive. Um, but that's a way to make it seem like the light is able to bounce around farther. So this actually went a little farther than I wanted it to go. So let's say I bring it back to 0.7, see what that gets us, and then we can move on from that. Point lights are pretty fast, as you can see. They're still not area lights. They're much like the spotlights, that they only have one point in space, so they don't need lots of rays to shoot out from the volume to sample them. So there we go. So that's better. Cool. In fact, I'm just going to delete this one. Great. So a combination of the inherent attenuation of the light, where it falls off quadratically, and then it's also slowed down even faster by the very density that's occluding it, really shadowing it in the first place. So there it is. And that's a good way to jump off and talk about the actual scattering phase on the shader itself. So the scattering phase itself here is a great way to give a sense of the actual particulate that the volume is made up of. It's strange to think of a volume as lots of little pieces of stuff suspended in air, but it's actually pretty critical to depict that accurately. For example, if this was steam, if you look up examples of steam, steam is of course made up of water droplets suspended in air, so they are clear and they transmit light through it in a way that light would pass through glass, as opposed to a soot, which are solid pieces, and yet they kind of still absorb light. And on the opposite end of that spectrum, you might have like flour or talcum powder, which is also solid but reflects light. So all those kinds of things can be captured with scattering phase. And basically all you need to know is here in the tooltip text, if the number here is above 0, and it's pretty drastic, you don't have to ever really even put this much higher than 0.2. If the numbers are positive, it's going to simulate light passing through. So I'm going to put 0.2. If it's 0, the light will both somewhat pass through and bounce back away from the volume. And if the number is negative, it will predominantly bounce away from the volume. So again, if it's positive, light will pass through, which suggests a transmissive kind of material. And those tend to be your steams or clouds even. Imagine looking at a cloud with the sun behind it. It's extremely bright because that light is not being bounced back, and as opposed to smoke passing in front of the sun or in any circumstance will make things darker. So as you can imagine, that's extremely important, those two wildly different outcomes. So check it out. So right away we see when I go here, less light is bouncing. All this stuff got darker. It got darker because the light coming in from our key distant light is more or less, it's hitting it, but a lot of it now is passing through and away from the camera. We're not even seeing it. Whereas this light here got brighter. See how it got brighter? That's because the light originating here in the center is coming at us. It was already trying to come at us here, but was being blocked somewhat. By increasing the scattering phase, more of it is actually allowed to pass through to us. So isn't that interesting that some of it got darker and some of it got brighter? And that's the way steam would behave. As opposed to, if we go the opposite way with this, you'll see that everything is going to get brighter now and this will get darker. And that's because all this light is going to be bouncing, off of the thing, which is how we see it, because the light is bouncing off of it. And this is becoming more occluded because the light from the inside is bouncing off the smoke and then more or less being sent back inside. It's pretty fast. Like, it doesn't really add any significant time to the calculation because it's not really doing a real scatter. It doesn't have to send any extra rays anywhere to do all this. It's just how the renderer knows that, okay, when the ray march hits density, how bright should it be? Well, it just takes the camera's direction and position to account to say, well, should this light be passing to the camera or not? And that's how we get these different looks. Very different. I'm going to go more with this kind, the transmissive kind of steam look. Just probably going to do like a kind of a subtle one. So I'll probably put this down to like 0.05. I'm going to render that just so we have it. And that is the scattering phase. So this is kind of something that is easy to ignore, but it's so important to capture the essence of the volume. It's not always just about the motion. It's absolutely about the look of it in this regard, and that's something something strange to think about again with water droplets in air. But that is exactly what's going on here. Cool. So that's scattering phase.